What we're going to look at now, you probably saw when you first encountered derivatives, except now we're looking at it through the lens of vector functions. A position function is represented as a vector function r of t. We've been calling this a curve up till now, and it's still a curve, but the vector now represents a position of a particle or some object. If r of t is position where t represents time, then velocity is represented by its derivative r prime of t. In this context, we're going to use v of t to represent r prime. Velocity is a vector because it communicates both speed and direction, but speed itself is a scalar. We saw in a previous section that speed is represented ds dt, and that was given as the magnitude of r prime of t, which we can now say is the magnitude of v of t. Acceleration is the second derivative of position, also the first derivative of velocity, and is denoted a of t. Working backwards, we can say that it follows that if acceleration is given by a of t, then velocity is v of t, the integral of a of t dt plus some constant. We're going to pick up a constant when we find the antiderivative. And position is r of t, which is going to be the integral of v of t dt plus some other constant that we'll pick up. As far as the constants, we would use initial conditions to find the constants of integration. This should be relatively familiar to you. The difference here now is when we're integrating a vector, so the answer is a vector in both of these cases. With this as background, we're going to look at projectile motion, and our projectile motion right now is going to be in R2. Acceleration is due to gravity. Gravity points down, so it's negative g, and it's in the j direction. G, depending on context, is either going to be 32 feet per second squared, or g is going to be 9.8 meters per second squared, depending on if we're in the metric system or the system used by the US. I believe it's called the imperial system. It is, I just looked it up. If a is negative gj, then v of t is going to be the antiderivative negative gtj plus v naught, where v naught is an initial velocity. And r of t, the position, is going to be negative 1/2 gt squared j plus v naught t plus r sub 0, which is going to be an initial position. I know that went by a little quick. It was 2 steps of anti-differentiating. Let's talk about the initial velocity vector v naught. A vector v naught with length v naught that we're going to give as a scalar. In other words, the magnitude of the vector v sub 0 is equal to the scalar v sub 0. And angle alpha with the x-axis is v sub 0 the vector is equal to v sub 0 the scalar times the cosine of alpha I plus the sine of alpha j. Notice that in the parentheses, the cosine of alpha I plus the sine of alpha j is a unit vector, and the scalar v naught gives it its magnitude. So v naught can be written, the vector can be written as v naught times the cosine of alpha I plus v naught times the sine of alpha j. Now what this is representing is, as we said, an initial vector, or initial velocity vector. And in the xy plane, we're looking at, say, a projectile that's been launched from some height. And it has an initial velocity, this vector v sub 0. The initial velocity has a length, it has an associated angle alpha, and based on that initial velocity, we can figure out the trajectory of the projectile. That's kind of the point of all of this. If that initial height is h naught, then r of t is equal to negative 1/2 gt squared I. Let's try that again. It's negative 1/2 gt squared j plus t times the initial velocity vector, which is the scalar v naught times the cosine of alpha I plus v naught times the sine of alpha j plus h naught j, because that's in the y direction. And that implies, by collecting components, that r of t is equal to v naught cosine of alpha times t I plus the quantity of h naught plus v naught times the sine of alpha t minus 1/2 gt squared, all that times j. That's the vector function for a projectile's position. From this, we get parametric equations of motion. X is equal to v naught times the cosine of alpha times t. Y is equal to h naught plus v naught times the sine of alpha times t minus 1/2 gt squared.